Thank you, Rajimishra ma'am. So we can move to the next participant, next presenter, Professor Mainak Ghosal sir. So I request Professor Mainak Ghosal sir, kindly please share your PPT. Sir will present the topic as a superplasticizer compatibility with cement properties, a study. So over to Professor Mainak sir.
Is I audible?
Yes, Rajimishra, you are audible. Mainak sir is there.
Yeah.
Is the screen visible? Hello?
Mainak sir, your voice is too down. Kindly please increase your volume.
Okay. Is the screen visible now?
Sir, it is still started the showing that has started screen sharing.
Is it coming? No.
Sir, are you facing problem, Mainak sir? So you just stop screen sharing.
It is showing your screen sharing is paused. Someone has paused, or I don't know.
Okay, you just stop sharing. Sir, you just stop your sharing.
Now seeing your screen sharing.
Sir, is it visible, sir?
Yeah, it is visible. Yeah.
Okay.
Now I'll go to PowerPoint mode, no? Yeah. It is coming?
Is it visible to you, sir?
Yeah.
Okay, sir, you can start your presentation and kindly please try to complete by 7 to 8 minutes.
Okay, no problem.
Okay, you just tell me when you have to change, okay?
Yeah, this is cement superplasticizer compatibility study. Myself, Mainak Ghosal from IIT Shibpur, and I thank the organizer to give me a chance to present here in this ICMMIT 2022. Now, these are table of contents, overview, introduction, literature survey, review, assignment, my work, and the conclusion, findings for reference. Now, coming to the topic, what is admixture? Admixtures are other than water aggregates, hydraulic cement or additives like pozzolana or slag fibers which are added in the batch in concrete to modify the property or of the fresh and the hard state. This is added to the mixture from outside. This is called admixture. And if you come to plasticizer, a type of admixture which reduces water in the mix by 8 to 10%. Now you see, Niti Aayog says that by 2030, 40% of Indians will have no access to safe and drinking water. And in top of that, in addition to that, it says the water demand by 2030 will double at respect to what it is at present now. So if we can reduce the water in the cement concrete, we'll get more work, and it will be more feasible to do work. And superplasticizer, it reduces water by 34 to 36% as far as the literature is concerned. Now, admixture types used in concrete. There are mineral admixture like fly ash, what we get from the power plant industry, ash type fly ash. After burning the coal, we get fly ash. Microsilica, a product from the iron silica industry. GGBS, ground granulated blast furnace slag, also product from the iron industry. Zeolite, colloidal silica, and CSH means your calcium silicate hydrate nano dispersion. At the level of nano, we are also getting mineral admixtures. Now there is much talk about nano in this conference. will come later. And there is also chemical admixture apart from the minerals. There may be viscosity modifiers, there may be accelerators, there may be bonding agents, there may be shrinkage reducing, there may be corrosion inhibitors, there may be waterproofing or the crystalline type. And supervisor, there are three types of supervisor at present we have. The first generation was lignosulfonate. From paper industry we got lignosulfonate. Then came sulfonated naphthalate formaldehyde or sulfonated melamine formaldehyde condensates from also byproduct from industry. And now the topic is on the polycarboxylate ether, the latest generation admixture, updated admixture, a supervisor type. Now PCRs are taking polycarboxylate ether. Supervisor types are two types. One is low adsorption short chain type. You are seeing the picture, the chains are short. These short chain types gives high workability and high resistance to chloride and sulfate attack. And there is another high adsorption long chain type we have, which have a high retention power. That means if the concrete tends to be fluid in the long run, so we have to carry concrete from ready-mix concrete for 100 km. It should not set. It shouldn't harden. It should remain in that fluid state. So for that, these long chain admixtures are supervisors are very useful. And it is also giving least resistance. It has problems with durability also. Will come. See. Now this is a paper effects of polycarbonate supervisor with different side chain lengths on resistance of chloride and sulfate attack. It says that electrostatic repulsion in cement. What happens? We add cement to water. Cement gets flock. It flocks and it flocks and it traps the water in it. Plain cement with water. Then if we add admixture, what happens? Admixtures impart opposite charge, and this disperses, and we get fluidity. More fluidity in the mix. More fluidity means more reaction of cement with water and more hydrogen products, more strength, like that. This is from source from the concrete portal I have taken. This repulsion, and for the PC, that the latest admixtures, repulsion. Apart from repulsion, we are getting steric dispersion of cement. That means these long chains, they tear apart the cement particles. Apart from the repulsion, they tear apart the cement particles, and more water is released. Like there, you can say. This is a paper from DOI 10.2478 I have taken. Now, role of supervisor. Supervisor makes number one, cement concrete flowable at low water cement. If you add low water, cement concrete will flow due to this more release of water of this by the supervisors. And another important is self-compacting. You do not compact concrete manually by the concrete pumpers or by the vibrators. It is self-compacting the concrete. This supervisor can make as per the literature reviews. Now, Portland cement has got 4 major phases. What our topic is cement and supervisor compatibility. So 4 major phases. We get dicalcium silicate 23%, tricalcium silicate about 60%, tricalcium aluminate 7%, and tetracalcium fluoride 10%. These are 4 major phases: C3S, C2S, C3A, and C4AF. Now, this tricalcium silicate reacts with water. We get to give calcium hydroxide. This calcium hydroxide is mainly responsible for the strength gain. And this C2S, another tricalcium silicate, another phase, reacts with water with less CaOH calcium hydroxide form. Now, tricalcium aluminate, this reacts with water to form these hexagonal phases, which are crystalline, typical forms. And this gives lower strength because calcium silicate hydrate and these crystals are contradictory. Calcium silicate hydrate is responsible for the strength gain, but this type of crystals are very much unstable. You see, but hydration is controlled by gypsum, and it gives flash shape. Like you seem to have idea that the cement has set, but it is not that. These crystals. So we have gypsum here. Gypsum is containing sulfate ions. The C3A reacts with gypsum to form ettringite, another crystal, and after all gypsum is converted to ettringite, excess C3A reacts with that ettringite, forming sulfur-aluminate hydrate. This is also a crystal. But higher C3A gives durability problems. So this type of so much crystals is forming, and which can tear apart the concrete also. So C3A content should be minimized. So not minimized, because in minimization we do not have the release of water. So it should be optimized rather. The C3A content at the ferrite phase C4A I was telling to 10%. This behaves more or less like C3S. We will not go into details of the ferrite phase. So what happens? The factors influence cement cement fineness. The more finer the cement is, the more water release will be from the flux. Cement composition, whether we are having sulfate, whether having what content of C3A, what of C2S and C4A, all those things, and superpressure composition. What is the composition of superpressure? Is it the first generation one, or the second generation, or the third one, the polycomposition ether? Now, superpressure cement interaction, cement without admixture tend to flocculate eventually in contact with water due to van der Waals forces and electrostatic retraction of the opposite charges. The opposite charges, see, this plus and this minus. Either I am getting the pointer, I think you know, so pointer option. Yeah. This plus and this minus, or rather this plus and this minus, they tend to attract, and that's why the shock is continued in the matrix and water is not released. This forms agglomeration of particles, and in presence of superpressure, this deflocculation or deflocculation or dispersion of cement particles occurs through absorption, and it is repulsion through absorption of the cement particles into the or rather on the surface of the acid molecule and repulsion takes place, because now we are getting all the positive charges in the cement particles, because this is negative charge. as it is more fine, a steric hindrance is possible only when high molecular superpressure are used. Now, what is steric hindrance? I told because of the long chains and the short chains. Now the comparative terms, what we are having in the clinker of the cement, what we are having in the gypsum which are adding to prevent the flash set, and what the superpressure constitutes, the sulfur ions or the high molecular weight or lower. These type of parameters are there in the comparative terms. This is a paper from influence of C3A for sulfonated based superpressure. Not very detailed. My research, I have taken cement 1 part, sand 3 part, water as per IS 4031, pasteurizers as per IS 9103, and about the superpressure. The pasteurizers means the first generation admixture. Now the water cement ratio 0.4. Now the density I have got. See, this is the graph. 7 day, 28 day, 90 day, 180 day, 60 day. This is the red one is the melamine formaldehyde, the old and superpressure. The new one is the green one, PC 1%, and I am getting an increase in the density of the cement concrete or the cement composites. Now cement composite strength at 7 day, 28 day, 60 day, I have got, see the result. This the red one is for melamine formaldehyde, the old generation admixture. I have got a strength gain of 29%, and for the latest, the polycomposition ether, latest generation admixture, I am getting a strength 41%. Yes, sir. I have got 1 minute. I will just finish it up.
Yeah, kindly please, sir.
Yeah. So 41% strength at the 1 year is a good sign of strength gain for the PC, the latest generation admixture. The conclusion is our cement codes are silent on the maximum limit of cement fineness, though the minimum limit of cement fineness has been specified in our code, and we should try to also the maximum limit, so that all the parameters can be controlled, or rather can be trial and error. And the C3A content should be at the optimum level, studying the SP, the superpressure and the gypsum contents, and the presence of sulfur ions should be studied before the superpressure uses or after the admixture uses. Thank you. Any questions you are having? I think I am on time.
Yeah,
10 minutes. This showing 10.41.
Yeah, thank you, sir, for your presentation. And I request now Dr. Deepak Kumar, sir, if sir is having any doubt, any query.
I have seen the presentation. So, sir has worked on the role of super plasticizer, especially on the development of the cement properties. So I want to ask one thing: if that sir has conducted any tensile strength analysis?
Tensile strength analysis I have conducted, but it is not at present the purview of my paper, so I should not go into details of tensile strength. I got good result in tensile strength. It is more than the
any kind of hardness, or how can you say that your strength has increased with the use of your plasticizers?
Yeah, compared to the reference sample, without using the plasticizer, what strength I have got, and with using the plasticizer, what strength I have got, then I have compared with The strength is increasing.
Okay, anyhow, it is indeed a very useful work, especially for the society.
Thank you.
Thank you, sir. Tanisha ma'am, are you having any queries? Okay. Mainak sir, I am having one little query. Is there any role of sulfate?
Yeah, because if you increase the presence of sulfate in the you are adding gypsum in the cement, increase the sulfate ions, then the C3A content will not get so much absorbed as in with the sulfate ions. So we get lesser, we get many, the property will change drastically.
Okay. Thank you, sir. Thank you, Mainak sir, because that must not having any. If there are any questions, we will directly in touch with your mail.
Yes,
okay. Thank you, sir, for your nice presentation. Now I'll move to the third presenter of this session, Dr. S. Sivamani. Sivamani, sir.